We're going to talk about rotational kinematics and energy equations for calculus-based physics. So if they say rotational or angular motion, we are traveling in a circle instead of a straight line. And even if we're traveling just at a quarter of a curve of a circle, that's still considered this circle. And almost always you'll have to imagine the circle in your mind. It won't be provided. So if we are on a Ferris wheel or on a circular track or a fan blade, we will have rotational or angular motion. In contrast to what you've done so far, which is linear motion, which is the default understood motion if it's not indicated, moving in a straight line. So most of the time you walk or you drive in a straight line. Angles are measured in radians, represented by RAD. An angle represented by the Greek letter theta is 0 with a line through it. And it shows the position. So rad is really short for radians, which is the angle measure, and using the pi value, but instead of using pi, it actually uses 3.14. And 2 pi, which is a full circle, is 6.28 radians. If you remember the unit circle, you can find the radians. Now, if we wanted to know what the radians value of let's say of 7 pi over 4, then we would just type in on our calculator 7 times 3.14, take that value and then divide by 4. And that would give us the radians value. Theta shows the position on the understood circle because we are talking about angular or circular motion. And theta is the angular equivalent of s or x in the linear values. Because s, what does s or x represent? It represents position or displacement. If you see theta naught is a subscript of 0. That is the starting position. Almost always the starting position is understood to be time equals 0. So before we started to take time, if it's not at time equals 0, it has to be indicated. So if they say from the beginning or from the starting position or at the initial position or at initial location, that is always going to be theta naught, and the naught is the subscript of 0. It looks like a W, but that is omega. Omega represents angular velocity. Angular velocity is the angular equivalent of linear velocity, represented by the letter V. Omega naught represents the initial angular velocity at time equals 0. So they won't always tell you time equals 0 there. They might just say omega naught, and you're supposed to know instantly that when you see omega naught, at that moment time equals 0. Alpha, which has a little bit extra curl to it than the regular letter A, that is the Greek letter alpha, is angular acceleration. Alpha is the angular equivalent of the regular or linear acceleration represented by the regular letter A. Alpha naught is the initial acceleration at understood time equal 0. So do recognize the similarities between the linear values and the angular values. So S, sometimes they use X, represents the position on a line, whereas theta represents the position on a circle. V represents velocity if you're traveling in a straight line, whereas omega represents the velocity if you are traveling in a circle or a spiral. A represents the acceleration traveling in a line. Gravity travels straight down towards the center of the Earth, whereas alpha is the acceleration traveling in a circle. So again, more similarities. The derivative of position is velocity. The derivative of velocity is acceleration. Just like in angular, the derivative of theta is omega, and the second derivative of theta, or the first derivative of omega, is alpha. So derivative-wise, linear and angular, you treat them the same way. So in other words, if you want to go from position to velocity, you take the derivative. If you want to go from velocity to acceleration, you take the derivative, regardless of whether it's linear or angular. And this is just another way to represent derivative. You can say s prime, or you can say ds dt. Notice that these values, because we are talking about motion, is always with respect to time. So we have d theta dt is omega. You could also think of it as the change in the angle with respect to time. With respect to time means how quickly it happens, is omega. So in other words, if you want to go from the angle to the velocity, you take the derivative. If you want to go from the angular velocity to the angular acceleration, you take the derivative. What if we know the acceleration and we want to find the velocity? Or what if we know the velocity and we want to know the position? In other words, it's kind of like we're traveling backwards from what the direction that we were just traveling. Or if you want to think of it like this, if we start with acceleration, then we have to take the integral. Because remember, integral is taking the antiderivative. It's the inverse. It's the opposite. So the integral of the angular acceleration is omega. Now notice there's that plus c. Plus c, you will always have to take the plus c, and to find your c value, you will have to plug in the given values. They should be given where you be able to plug in every value except for c into that equation. If you know your velocity and you want to find your angle, otherwise known as position, then the integral of your velocity is your angle and then you need a plus c. Sometimes your c is 0, but you do not know that. So in other words, if you want to go from angular acceleration to angular velocity, you take the integral. If you want to go from angular velocity to find your angle, you take the integral. They might ask you to find an instantaneous value or an average value. Your instantaneous value, they should give you your t value, or you should be able to find your t value. You plug it into the equation, you're done. Now if they want you to find the average, they'll still probably only give you one t value, but they'll say, what is the average value for the first 5 seconds? So the first 5 seconds means that you start at time equals 0. So what you have to take from there is you have two t values, t equals 5 and t equals 0, or whatever the given or understood t value is to use. And if you plug in 0 for t and you get 0, then that's fine. But remember, what is average? You find the two values, you add them together, and then you divide the two values by 2, and that should do it.